Okay, guys, we're going to do a few of these progress check problems that you turned in a day or two ago. Just going to go through them because a lot of people had trouble on some of the ones that should have been easy. And then some of you had trouble on ones that were supposed to be hard, and that's totally fine. So I'm going to quickly just run through some of them, not all of them. I just picked out a few. Um, they were in a random order when you took it. So this doesn't necessarily mean question eight on here was question eight for you. But this is where we're going to start. So this one says the least squares regression model, blah, 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 and correlation coefficient 0.66 were calculated, yada, yada, yada. Which of the following is closest to the proportion of the variation in y that cannot be explained? So this one should have been really easy for us, but a lot of people got it wrong, and so I was confused about that. Please remember that the proportion that can be explained is r squared. So we're going to take 0.66, which was r, and square it. Okay, so I'm going to round that. So 44% can be explained. Can be explained. 44%. Where am I going? Back here? Yes. So if 44% can be explained, the rest can't. And so 56% cannot be explained. And so that one was C. Okay, that was number 8. I also picked out number 9 as one I wanted to talk about. It says a botanist created a linear model to predict plant height from soil acidity. Sometimes it's just hard to read these because it's topics that you're not super familiar with. And so you just have to really buckle down and read them. So we're predicting plant height. The slope was 2.5, the deviation was 4, and the deviation of the soil acidities was 1. So it asks you what is R. And so, everybody should have gotten this one right also. We know that R, well, here, I don't have a blackboard to write on right now, but you know that R is part of the slope calculation, right? You know slope equals R times the deviation of y over the deviation of x. And so they gave us one, two, three of the four pieces. And so I'm not going to run through the calculation because I don't want to write this on the screen. But you have three of the four pieces of that calculation. All you needed to use was that little slope formula. So go back and do that one again. That one we should have missed. Number 10, I wanted to also talk about. What is it? Oh, baseball. Okay, in baseball, two stats, the ERA and the WHIP are used to measure quality of pitchers. Blah, blah, blah. Okay, I think the hard part about this one was this computer output right here. So we haven't spent a lot of time or almost any time looking at computer output yet. And all these things are going to make sense to us later. Right now, most of them don't. And the only things that make sense are the word intercept and its value. And then the other word, which in this case is whip, and its value. So again, computer output, here's all we need to know for right now. Intercept is that number. Slope is that number. And so once you know that, it's not all that hard to answer this question. Which of the following is the best interpretation of the value 6.8? Okay, 6.8 is the slope. And what are we trying to predict here? We are trying to predict ERA. Okay, so here's the deal. The slope, remember, based on our model, we predict that for every change of 1 in the x value, whatever x is, and so x is WHIP. So every increase of 1 in WHIP, there tends to be an increase of 6.8 in ERA. Well, that's this one right here. ERA is predicted to increase by 6.8 for every 1 unit increase in WHIP. So for every 1 unit increase in WHIP, ERA predicts or tends to go up by 6.8. So that one was A. Let's do 11. 11. Jordan is working on a business model for a sandwich shop based on past data. There's your model. Predicted number of turkey sandwiches sold for P dollars. All right, so it says, what's the best description of the slope? Well, the slope is -3. And so, without even looking at the answer choices, I'm covering them up with my hand. We would say, based on our model, for every increase of one, I guess it's dollar. So for every increase of $1 in the cost of the sandwich, sales tend to go down by 3 turkey sandwiches. Well, which one is that? Increase of 3. Increase of 3. Increase of 1. So it's C, D, or E. So for every increase of 1, the number of sold is predicted to decrease on average by 3. That's it right there. So again, not tricky, but we had people get it wrong. And so that is frustrating. This next one, again, computer output. Researchers investigating how the amount of monthly rainfall affects the monthly growth of a plant. You would think as rainfall goes up, the plant grows more, right? So again, here's computer output. The intercept is 0.75. The slope is 0.15. All right, which of the following is an interpretation of 0.75? Well, 0.75 is the intercept. Sometimes remember the intercept is meaningless, but in this case, let's think about what it would mean. An intercept is 0, 0.75. So that would mean, based on our model, that when it doesn't rain any in a month, the plant, whatever it is we're talking about here, a certain plant, tends to grow 0.75 inches. So without any rainfall, the plant tends to grow 3/4 of an inch. Okay, well, that's got to be down here somewhere. There it is. For a month with 0 centimeters of rainfall, the growth is expected to be about 3/4 of an inch. So I hope we missed that one because of the computer output and not exactly understanding it. That's my hope. 13, the following scatter plot shows monthly sales versus advertising dollars. Which of the following points is likely high leverage? You missed this one because you didn't know what that meant. We learned that yesterday or today. I don't know. It depends when you're in class. So which is high leverage? Remember we said leverage is far to the left and far to the right. And so, you know, these guys over here have some leverage. This guy definitely has some leverage. He's probably the answer. I'm just guessing. 5.1, 105. Found it. There it is. Okay, so high leverage, far left, far right. Skip to 15. Just going to do a couple more. 15. The following scatter plot shows the ages of 12 of the wealthiest people in the world. This is okay. So yeah, as people get older, they tend to be worth more. At least the super wealthy people, except for this person. Suppose point Q is removed, which is likely not affected. Ooh, good question. So if we took out Q, oh boy. So visualize the best fit line right now. Maybe it goes, it's drawn a little bit down by Q. Without Q, it would go, those are terrible sound effects. So what is not affected? I don't know. Let's look. The correlation coefficient. No, that would definitely be affected by taking out Q. It gets stronger by taking out Q. The sign of the slope coefficient. Well, slope right now we said would be positive. And if we took out Q, it would be more positive. So I'm thinking this is the answer. The sign of the slope coefficient is not changed. The value of the slope is changed a little bit. It gets steeper. The sum of the squared residuals. This is a complicated sounding one. The sum would get smaller because the residuals would be closer to the best fit line. And the intercept, well, right now the intercept's probably down here somewhere, let's say between 10 and 20, and it goes this way. If I redrew the line, the intercept would be, I don't know, down lower, so the intercept is changed. So the only one that is not changed is the sign of the slope coefficient. That took a little bit of thought, but not enough that we should have gotten it wrong. Let's see, 16. Real estate. Okay, this one was hard because we haven't really talked about um, logs and square roots and squaring and all that kind of stuff very much. Just for a minute one day we did. So a real estate agent wants to predict the selling price of homes from the size. You would think as the size goes up, so does the price. Not surprising. The price is in thousands. The size is in hundreds of square feet, and that's confusing also. So here we go. Based on the model, which of the following is closest to the selling price for a house that is 3,200 square feet? Okay, so if a house is 3,200 square feet, that's 32 hundreds. So we're going to put the number 32 right there in place of size. So I'm going to go to my calculator. So 0.11 times 32 plus 2.08. Remember that. 0.11 times 32, 0.11 times 32 is that, plus 2.08. Enter. Okay, so what is that? 5.6. So here's the equation that we have right now. Now we're going back to Algebra 2 land. This says the natural log of x, or of something, equals, what was it, 5.6? So ln x equals 5.6. And please, oh, we're going to algebra 2 land for real here. So if I'm going to try to write this using my mouse. Oh my gosh. This is an algebra 2 quick refresher. Whoa, that's messy. 5.6. So please tell me you remember how this works. When you have a natural log, the understood base is e, and I hope you remember this means e to the 5.6th power equals that thing. So e to the 5.6 equals that. So let's do that. E to the 5.6. So this was hard. Where is my e key? Found it. E to the 5.6. Boom. What does that say? 270. And that's my price of my house, 270. Price is in thousands. Hey, look, 270,000. Shocking. Found it. So a little hard, but doable. Doable by the smarty pantses that you guys are. Last one, I promise. 17. This is it. Oh, this one looks hard. What are we doing here? Workers at a warehouse gather items, blah, blah, blah. The number of items it takes, yada, yada, yada. Blah, blah, blah. Okay, so what's the question? Based on the regression output, which of the following is the predicted time? Okay. The only reason this one is hard is look right here. So in other words, here is the intercept where it says constant, that's your y-intercept. And here's your slope. 2.76 is the slope, but it's not 2.76 times x, it's times the square root of x. And so if you were to write out this little equation, I'm going to do my best here again with my mouse. You'd put whatever y is, you'd put y hat equals, I already forgot the intercept. Gosh darn it. What's the intercept? 3.09. I'm going to round that to 3.1 because actually it rounds. So there's my intercept, 3.1 plus the square root of, I forgot the numbers already. So 2.76 is the slope. I wrote this in a terrible order. So here's my slope, 2.76. Oh my goodness, I am just struggling with this pen. All right. So here's how this should look. It should say y hat equals 3.1 plus 2.76 root x. I wrote it kind of backwards. My fault on that. But let's figure out the answer to this question. We have 22 items, and so all I'm going to do is come back to this equation and plug a 22 right there. So I'm going to do this one in my head, just rough estimating. The square root of 22 is, between 4 and 5. Let's say almost 5. If I have almost 3 times almost 5, that's going to be like almost 15 plus 3. The answer is in the 16 to 18 range. Is that fair enough? That's using estimation skills. 16. Oh crud, there's 2 answers. Okay, so you really should have used your calculator. It's one of those two. I don't know which one it is, but it's pretty easy to figure out. Okay, those are the ones I wanted to go through. Hey, pretty good job for the most part on these, but I thought maybe some of you would like to see some of those answers. So hope that helped. Hope you watched it. If you did, tell me about it in class. Tell me thanks for that video. It helped. I liked it. If you think it didn't help, tell me that in class. Say, Willard, your video is awful. Don't do that anymore. That's it. See you later.